Hi everyone, today my video is about strictness and lazy evaluation. There are many possible evaluation strategies for evaluating a program based on execution speed and program correctness. There are two classes of evaluation strategies, strict evaluation and non-strict evaluation. Lazy evaluation is one non-strict strategy. What do you mean by strict evaluation? Here a function is only evaluated after its arguments have been evaluated. Then what is lazy evaluation? Argument evaluation happens only when arguments are needed. The subcomponents of many expressions can be evaluated in more than one order. There are two order, applicative order and normal order. So what do you mean by applicative order? If we evaluate function arguments before passing them to a function, it is called applicative order. Then what is normal order? If we pass the arguments unevaluated into a function, it is the normal order. Normal order evaluation is also called what is lazy evaluation. The scheme uses applicative order in most cases. So applicative and normal order evaluation, here we can see define double lambda x plus x's. In applicative order, it means double star 3 4. Here it is double 12, then it is plus 12 12. It is evaluated to 24. Then under normal order evaluation, double star 3 4 is there. Then plus star 3 4 star 3 4 plus 12 star 3 4 the plus 12 12. It is evaluated to 24. Now we end up doing extra work. Normal order causes us to evaluate star 3 4 twice. A side effect function is said to be strict if it is undefined. It is fails to terminate or encounter an error when any one of its arguments is undefined. Such a function can safely evaluate all its arguments, so its result will not depend on evaluation order. A function is said to be non-strict if it is sometimes defined even when one of its arguments is not. A language is said to be strict if it is defined in such a way that functions is always strict. A language is said to be non-strict if it permits the definition of non-strict functions. If a language always evaluates expression in applicative order, then evaluation function is guaranteed to be strict because whenever an argument is undefined, its evaluation and will fail. A non-strict language cannot use applicative order, it must use normal order to avoid evaluating unneeded arguments. ML and scheme uses are their strict languages, Miranda and Haskell are non-strict. This is lazy evaluation. Lazy evaluation is one non-strict evaluation strategy which holds the evaluation of an expression until its value is needed. It allows repeated evaluation. It allows language runtime to discard sub-expressions that are not directly linked to the final result of the expression. And it reduces the time complexity of an algorithm by discarding the temporary computations and conditionals. It is best suited for loading data which will be frequently accessed. Lazy evaluation is used for all arguments in Miranda and Haskell. It is available in Scream through a split use of delay and force. Delay and force constructs allow you to use lazy evaluation in scheme. For example, define expression delay plus a10, define a15. The expression becomes when force expression it is evaluated to 25. Delay binds an expression to a name and force forces the evaluation of an expression. Scheme uses memorization to save the value of the evaluated expression where the force is called force is called a gain. It simply returns the cached value. The problem with the lazy evaluation, the principal problem with the lazy evaluation is behavior in the presence of side effects. If an argument contains a reference to a variable that may be undefined, modified by an assignment, then the value of the argument will depend on whether it is evaluated before or after the assignment. If the argument contains an assignment, values elsewhere in the program may depend on when evaluation occurs. So lazy evaluation drawbacks are there. It forces the language runtime to hold the evaluation of sub-expression until it is required in the final result by creating thunks or delayed objects. Sometimes it is increases space complexity of an algorithm It is very difficult to find its performance because it contains tons of expression before their execution. So this is about